In this video, we're going to do yet another example of a volume of a solid using cylindrical shells. Just in this case, we're going to go about rotate around a vertical line. So we have the region bounded by the curves y equals x and y equals 2x plus over 1 plus x cubed. And we're going to go about the line x equal to -1. And right now, we don't have the machinery to do this integral by hand. So we will do this integral with our calculator at the very end. All right, let's first understand why we're going to do this with shells rather than washers. We've got two very, very good reasons why we're going to do this with shells rather than washers. The first reason is, look at this region. If we were going to do washers, we would have to slice perpendicularly to the axis of rotation. Okay? Notice that we would have a right curve minus a left curve, and right here at the top, we've got, this would be our right curve, and down below that, we'd have this is our right curve. So we've got this, the 2x over 1 plus x cubed curve is our right curve for a while. Otherwise, it's the line. So we would have to do two integrals if we were going to do this with respect to y. That's reason one why I don't want to do this with respect to y. Reason two is even more important. To integrate with respect to y, I have to have a function of y, which means, in particular, I'd have to solve this sucker with respect to for x in terms of y. I really do not want to solve that for x in terms of y. That would not be a fun thing to try to solve. So, those two things together are telling me I want to integrate with respect to x. I've made that decision to start with. If I'm integrating with respect to x, that means I'm slicing the x-axis up. I'm slicing vertically, which means that we are parallel to our axis of rotation, which means we are using shells. Okay? So the fact that I'm choosing to integrate this with respect to x tells me I have to use shells. So I have no choice if I'm going to integrate with respect to x. Okay. All right. So again, for shells, we need a radius and a height. Again, I think the height is the easier of the two. It's always going to be either top minus bottom or right minus left, depending on if you're doing with respect to x or with respect to y. In this case, if you're doing with respect to x, the top curve is the 2x over 1 plus x cubed. The bottom curve is the y equals x curve. So that difference is the height of the shell. Radius is always going to be the distance from the slice to the axis. Our slice is at an x coordinate of x, because it changes depending on where we are in the interval. It goes from x to -1, so x minus -1 is the radius. All right. So that's our radius, and this is our height. The other thing we need are our limits of integration for our x's. Setting the two functions equal to each other and solving for x. We get x to the fourth minus x equals 0 when we clear our fraction here. We factor out an x, we get a difference of 2 cubes. We get an x cubed minus 1, so we have an x minus 1 times an x squared plus x plus 1 is how that factors. This has complex roots, so the only real roots we have are 0 and 1. So that's why our integral goes from 0 to 1 here. This is our integral, and then using either a calculator or a computer algebra system or what have you, you can approximate this integral to be 2.36164.